Now coming to the case 2. What is the case 2? So possible remainders are 0, 1 or 2. So we proved that case 1 by taking remainder as 0. Now coming to the remainder value as 2. If remainder is 1, if r equal to 1, then n equal to 3q plus 1. Substitute one value in the place of n equal to 3q plus r. So you will get, when r equal to 1, then n equal to 3q plus 1. Okay, so this is the case 2, that is n equal to 3q plus 1. So n equal to 3q plus 1. So it is clear that it is not divisible by 3 because 3 multiple plus something. So it leaves the remainder as 1. So it is not completely divisible by 3. So n equal to 3q plus 1 is not divisible by 3, as remainder is 1. So what will be the value of n plus 2? Now coming to the n plus 2. Here n is 3q plus 1. So what will be the n plus 2? That is 3q plus 1 plus 2. Substitute n 3q plus 1 in the place of n. That's why n equal to 3q plus 1 and plus 2. Okay. So this is 3q plus 3. 1 plus 2 equal to 3. Now in these two values, 3 is the common term. So if you take 3 as common term, you will get q plus 1. Now this is in the form of 3 multiple, 3 into something. 3 multiples are always divisible by 3. So it is clear that it is divisible by 3. Is divisible by 3. Okay. Now coming to the n plus 4 value. So what will be the n plus 4 value? Let me check. N is 3q plus 1. That's why this is 3q plus 1 and next 4. So that is 3q plus 5. And you can write 3q plus 5 as 3 plus 2. Okay. So from the first two terms, you can take 3 as common term. Now take the 3 as common term. Then you get 3 into q plus 1 plus 2. So it is clear that this is 3 into something plus 2. So when it is divided by 3, leaves remainder 2. 3 multiples are always divisible by 3, and here extra value is 2. So when it is divided by the 3, it leaves 2 remainder. Okay, so is not divisible by 3 as remainder is 2. Okay, so children, you can observe that if r equal to n, then n equal to 3q plus 1. In this case, n is not divisible by 3. n plus 2 is divisible by 3. And n plus 4 is not divisible by 3. So in this case also, only one out of these three values is divisible by 3. Okay. So write the conclusion. Therefore, in this case, 1 out of n plus 2 or n plus 4 is divisible by 3. Okay. So second case also verified. Now coming to the case 3. What is case 3? If r equal to 2, then n equal to 3q plus 2. Now check which value is divisible by 3 when n equal to 3q plus 2. Okay. So first one, n equal to 3q plus 2. It is not divisible by 3 because when it is divided by 3 it leaves remainder 2. So because 3 multiple plus 2, so it leaves 2 as a remainder. Is not divisible by 3 as remainder is 2. Now coming to the n plus 2 value. So what will be the n plus 2 value? Here n is 3q plus 2. So write the n value 3q plus 2 and next write the plus 2 also. So that therefore this is 3q plus 4. Okay. So you can write 4 as 3 plus 1. Now from these two terms you can take 3 as common. So if you take 3 as common you will get q plus 1. So that is 3 into q plus 1 plus 1. It is also clear that when it is divided by 3 it leaves the remainder 1 because 3 into something plus 1. So this is also 3 into q plus 1 is not divisible by 3 as remainder is 1. Now coming to the n plus 4 value. So now n plus 4. What is n here? 3q plus 2. That is 3q plus 2 and write the 4 as it is. So this is 3q plus 2 plus 4 is 6. Now you can take 3 as common term. So now if you take 3 as common you will get 3 into q plus 2. So it is clear that this value is 3 into something, that is 3 multiple. 3 multiples are always divisible by 3. You know that. So therefore it is divisible by 3. So in this case also, if n equal to 3q plus 2, then n is not divisible by 2 and n plus 2 is also not divisible by, if n equal to 3q plus 2, n is not divisible by 3 and n plus 2 is also not divisible by 3. Only n plus 4 is divisible by 3. So in this case also, only one out of these three values, that is n, n plus 2 or n plus 4 is divisible by 3. Okay. So from these three cases, you can conclude that only one out of n or n plus 2 or n plus 4 is divisible by 3. Okay. So therefore, in this case, 1 out of n, n plus 2 or n plus 4 is divisible by 3. Okay, hence showed. Okay, this is the solution for the last problem.